So welcome to another session of Everyday Mathematics. Today's problem is problem number 8 in the MIT 2024 Integration B regular season set of questions, which is the indefinite integral of the arctangent of square root of x. So interesting problem. Before I jump into trying to solve this problem, I'd like to thank our subscribers. Thank you so much for the support you're continuing to show us. We really appreciate your support. We don't take it for granted. Our first-time visitors here at Everyday Mathematics, what we do is we go about and around and look for interesting problems, and we come back and share with you the solutions that we think befit these problems. To our repeating visitors who haven't subscribed, we do really encourage you to consider subscribing to our channel. So it's a very interesting problem. On to the solution. One thing I would do is to let u be equal to that square root of x, and this is just a personal proclivity that I substitute for what seems to be a complicated expression with simpler ones. So when that is the case, then u squared is equals to x, and so 2u du dx is equals to 1, and therefore we can substitute dx with 2u du. Yeah, so that comes from obviously multiplying with dx on both sides, left and right. And so now arctangent of square root of x integrated is the same as arctangent. In place of square root of x, we have u. In place of dx, we have 2u du. And so we can pull out the constant u, and so we have the integral of u, arctangent of u. And now we can also express u as a derivative of u squared times a half, and then times arctangent of u. Now we can use now integration by parts, where if you have the integral of the product of u and dv, the result is uv minus the integral of vu du, right? And therefore, if now we set u to be arctangent of u, and then therefore du, capital U, or is the same as this the derivative of arctangent of u, which is 1 over u squared. And if dv is the derivative of u squared, then it means that v is u squared. And so since this 2.5 here cancel, therefore the derivative of u squared times arctangent of u is the same as uv, which is u, which is arctangent of u, and v, which is u squared, so u squared times arctangent of u, minus v du, so v here is u squared, du is 1 over u squared. And now we can do long division here, just to make things easy. So if you have u squared here, and you have 1 plus u squared outside here, multiply by 1, so we have u squared plus 1 here, and so we have a difference, a residue of -1. So this fraction here is the same as 1 minus 1 over 1 plus u squared. Yeah, and this coming from here, and this -1 here coming from this portion here. And so now we can plug that in here. So we have u squared, arctangent of u, minus 1 over u squared. Okay, so integrating 1 minus 1 over u squared, the integral of 1 is going to be u, and then the integral of 1 over 1 plus u squared is the non-arctangent of u. Okay, we won't go into details on how to integrate this. It's a very obvious thing. And then so collecting like terms, u squared and 1 here, so u squared plus 1 times arctangent of u minus u plus c. But since we had initiated our substitution with u being equal to square root of x, then wherever u appears, we have square root of x, therefore meaning that u squared is x, And so the arctangent of square root of x integrated is the same as plus of u squared x plus 1 arctangent u being equal to square root of x minus here u, we have square root of x plus c. And this is our answer here. Very interesting problem. I hope you did enjoy following along. If you have any questions, please feel free to leave a question or comment in the comment section. We'll be glad to get back to you. Until next time.